and welcome to a video on arithmetic and geometric sequences. So today we're going to write and graph terms of arithmetic and geometric sequences. We're going to determine whether a sequence is arithmetic, geometric, or neither, and then we're going to write arithmetic and geometric sequences as functions. So we're going to start off first with arithmetic. So in an arithmetic sequence, the difference between each pair of consecutive terms is the same. And this difference is called the common difference. So again, we know difference means subtract. And so to find the common difference, you would pick a term and then subtract the one before it to figure out your common difference. So for example, in this problem, I've got 5, 10, 15, 20. I can see that they are adding 5 each time, and so that is my common difference. So again, one way of finding the common difference would be to pick a number and then subtract the one before it if you were struggling to see the pattern. Okay? So example 1, write the next 3 terms of the arithmetic sequence. So first off, you have to figure out the pattern. So how did they go from -7 to -14 to -21 to -28? Let's say you're not the best at mental math. To figure it out, you would pick a number, so -21, and subtract the one that comes before it, which would be -14. Okay, so -21 subtract -14. Now I know 2 subtractions is the same as addition. -21 plus 14 is -7. So my pattern is they are subtracting 7 every time. So -7 take away 7 is -14. -14 take away 7 is -21, and so on and so on. So to figure out the next 3 terms, you're going to continue that pattern. So you would say -28 subtract 7 to get -35. Keep going, subtract 7, -42. Keep going, -49. So the numbers were consistently getting larger negatives. Okay? So again, if mental math is difficult for you, you pick a number, subtract the one before it, and that will tell you your common difference always. So you guys try the next 2, press pause, and then we'll go over the answer. Alright, so for our first one, you should have gotten 120, 90, and 60 were the next 3 terms in your sequence. Again, you can maybe easily see that they're subtracting 30. If that was a struggle, again, pick a number. I picked 180, subtract the one that comes before it, and that will tell you your common difference of -30. Same thing for this right one. Our numbers were increasing, so they were adding. Again, if you don't know what they're adding by, pick a number, subtract the one before it. That will tell you your common difference immediately. So that works for arithmetic sequences. So again, arithmetic is going to be adding or subtracting. The next kind of a sequence is called a geometric sequence. So in a geometric sequence, you no longer have a common difference, you're going to have a ratio. And so in a geometric sequence, the ratio between each terms is going to be the same, and this is now called the common ratio. We know that ratio means multiplication or division. If you think ratio, you think fraction. And so for common ratio, you're trying to figure out what are they multiplying the previous term by. So some of them are pretty easy. It's going 1, 5, 25, 125. You're asking yourself, how do they go from 5 to 25? They multiply by 5. Now, if times tables aren't your thing, again, pick a number. And the last time we subtracted, but since it is increasing rapidly, you're going to divide by the one that comes before it. So pick a number, divide what comes before it. I know 5 divided by 25 is 5, therefore they are multiplying by 5. So that's kind of a foolproof way of finding your common ratio if your times tables is not your thing. So let's look at some examples. Write the next 3 terms of each geometric sequence. So I've got 1024, 256, 64, 16. I can see that these are drastically decreasing, okay? So I know they're dividing by something, okay? Again, if you don't know, we can pick a number and divide the one before it. So what that would look like, I'll pick 16, divide the one before it, okay? And then we'll type that in the calculator. 16 divided by 64 is going to be 1/4. Okay, so what is happening is they're actually multiplying by 1/4. Now, multiplying by 1/4 is the same as dividing by 4. Okay, so trying to help you figure out the next 3 terms, it doesn't really matter whether or not you see that they're dividing by 4 or multiplying by 1/4, but that will help us out. So if they're dividing by 4, and I continue that pattern and divide by 4, 16 divided by 4 is 4. 4 divided by 4 is 1. And then 1 divided by 4 is a fraction, 1/4. So my next 3 terms would have been 4, a 1, and then 1/4 or 0.25. Okay? So let's do one more. In the next one, I notice I have 81, -27, 9, -3. So I notice they're kind of jumping all over the place. We go from positive to negative to positive to negative. Okay? So for right now, I'm going to kind of ignore the negatives and just look at the positive numbers. How do I go from a 9 to a 3? Well, you divide by a 3. Let's see if that checks out. 27 divided by 3 also gets me 9. Now, I do notice I'm going from positive, negative to positive to negative. And so what that means is you're actually dividing by a -3. Okay? Now, again, if finding the pattern is difficult for you, pick a number. -3, divide it by the one that comes before it. Okay? So -3 divided by 9 ends up being -1/3, which again that's the same as dividing by a -3. So multiplying by a -1/3 is the same as dividing by a -3. So now that I've got my pattern, my common ratio, I need to figure out the next 3 terms of my sequence. So I'm going to stick with the dividing by a -3. Negative divided by a negative is a positive, and then 3 divided by 3 is a 1. So my next term is going to be a 1. Now I would have to do 1 divided by a -3, which again is a fraction, and it's going to switch back to a negative number. So I've got positive, negative, positive, negative, positive, negative. I know my next one's going to be positive of some sort. So then I would have -1/3 divided by 3. So again, you can type that in the calculator. You would get positive 1/9. Because 3 times 3 is 9. So notice this pattern became a fraction because we started to get smaller and smaller and smaller. But notice this 3 denominator matched up with that 3. This 9 denominator matched up with that 9. So the next one would be 1/27, or -1/27, and so on and so on. All right, so you guys try the next 2. See if you can find the geometric pattern, and then tell me the next 3 terms that would be in that sequence. So press pause and try those. All right, so on the next one, I was able to see that they were multiplying by 2, and my numbers were increasing rapidly. Again, if you struggle with that, pick a number. 24, divide the one that comes before it. That tells you a 2, so you know they're multiplying by a 2. Same thing over here. My numbers were going from positive to negative, so I know that pattern's going to continue. Now again, if you struggle to find it, pick a number. So -1, divide the one that comes before it, which is -1/4. And so multiplying by a -1/4 is the same as dividing by 4. And so if you continue that pattern, we get the rest of the numbers. So I do want you guys to actually try example 3 as well. So they're kind of jumbled now. So we've talked about arithmetic as adding or subtracting. We've talked about geometric as multiplying or dividing. And so now you guys are going to tell me which is which. So it could be neither, or geometric, or arithmetic. So take some time and try A through E. So press pause right now. All right, so A was geometric because they were either multiplying by a half or dividing by a 2. Part B was neither. So first off, I checked, okay, multiplication. But then that multiplying by 3 didn't repeat through the whole way. So then I was like, well, how'd they go from 6 to 11? They added 5. So I learned that they were adding 4, then adding 5, and then adding 6. So I found a pattern, but that difference was not the same every time. Therefore, it was neither. C was subtracting 3 every time. That would make it arithmetic. D was dividing by a 4 every time, or again, multiplying by 1/4, which would make it geometric. Again, E had a cool pattern. They times by 2, then they times by 3, then they times by 4, so you would think multiplication would make it geometric. But again, that ratio would have to be the same number to make it arithmetic. Okay? So that's kind of figuring out arithmetic geometric sequences and figuring out a pattern. So now we're going to take a look at some graphs. So graphing. Example 4, graph the arithmetic sequence, and what do we notice? So when we're graphing, we need to order pair. I only have one set of numbers, so what we're going to do is we're going to say that 4 is the first number, 8 is the second number, the third number is 12, and the fourth number is 16. So now I have an ordered pair to graph. So I'm going to graph 1 and then a 4. So to the right, 1 at 4, 2 is going to be at an 8, 3 is at a 12, and 4 is at a 16. So after plotting these points, what do we notice? Well, I notice that all these dots are pretty linear. Okay? So an arithmetic sequence on a graph is going to look very linear. Now let's try the second one. I've got a geometric sequence. Again, I've got 32, 16, so on and so on. Again, first number, second number, third number, fourth number, fifth number. So if I graph that, too far. So first number is 32, second number is 16, so not quite linear. It's actually got a little bit of a curve to it, and so if we remember, this would actually be exponential decay because my graph is going down very rapidly. So in this problem, they were dividing by 2. So they were halving it every single time. So again, dividing it is going to turn into an exponential graph. So the big kind of takeaways here is arithmetic sequences are going to look linear on a graph, and geometric sequences are going to look exponential on a graph. So that'll come important when we start to write equations. But try example 5 on your own. Figure out if these graphs are arithmetic, geometric, or neither. And I am trying to trick you on some of these, so make sure you pay attention to your numbers as well as what the graph looks like. So press pause for right now. All right, the first one even got me. I was like, this looks exponential. However, when you look at the numbers, 3, 4, 7, and 12, they're not multiplying by anything. So that was actually neither. This next one, it is arithmetic. So you've got 5, 5, 5, 5, which is the same as adding 0. Now, some people kind of want to argue, well, hey, you can multiply by 1. Wouldn't that make it geometric? No, it would not. Because, again, notice this is a very linear graph. That is why it would be arithmetic and not geometric. This last one, was again arithmetic. So there was no geometric in these examples at all. So we had 15, 35, 55, 75. They were adding by 20, very linear, which would make that arithmetic. Okay, so that is part 1, identifying arithmetic and geometric sequences. So head to part 2, where we will learn how to write them.